Welcome, my friends, to a very quick tutorial on a topic that is becoming popular again on the PMP exam. The topic is net present value. Net present value is an important topic because it touches finance and making financial decisions, project selection decisions, portfolio decisions, program decisions, and so on. We can say that net present value is a financial metric and it helps us put the time value of money concept in proper perspective. Talking about the value of cash flow, we have a formula that helps us deal with problems that we might encounter on the PMP exam. When we talk about the value of cash flow in today's dollars, it is important that we have a way of converting what is promised in the future to understand, okay, you're promising me $10,000 4 years from now. What is that money actually worth today? You see, because $10,000 today is worth more than $10,000 in the future. So if someone is promising you that money in the future, you better have accounted for inflation and so on. So if a friend offered you $100 today or $100, let's say in 2029, which one would you accept? The one that you would accept is the one that has more value, which is $100 today, or whatever the amount is, right? So when we talk about net present value, we have a formula. We're going to have a summation of the cash flow over a number of years, and we're going to consider the discount rate, and we're going to consider the number of years, add that all up, and that gives us what we call the net present value. Now, it's easier said than done. To get a very good idea of what NPV looks like, we would have to look at some calculations. So why don't we start off with a very basic calculation for a question about the time value of money. So the question goes like this. I've demoed this on the channel before, but now we get the chance of writing it all out. So if you are tuned into this channel, you might have seen me talk about this before. So the question reads, a project requires an initial investment. So let's put this over here. An initial investment of $225,000 and is expected to generate the following cash inflows. So in year one, we expect these cash inflows, $95,000. In year two, $80,000. Year three, $60,000. And year four, $55,000. And then the question, which will enable us better understand this, ends with this request. Compute the net present value of the project if the minimum desired rate of return is 12%. So we are going to use a formula. This one. Net present value equals the summation of the cash flow over the time periods and factoring in the discount rate. This means we need to understand the investment of $225,000 is a negative cash flow. That money is going out, not coming in. So that's going to be looked at as negative to begin with. And then all these other monies are going to be looked at as positive cash flows. When we talk about cash flow, this is cash flow right at the top. So we are going to apply this formula one time for that and 4 times for each one of these. So it does get pretty intense. But once you remember this formula and you have a calculator to hand and you know how to manipulate decimals, it will be more manageable. All right, so let's get rolling with this. Let's start off with the very first item on the list. So I'll do this on the right hand side of the screen so that you can follow along. And let's change the color over. Okay, so with this in mind, we are going to apply the awareness of the initial investment of 225,000. So that would be looked at as year 0. So in year 0, without going too far, we know that we have spent that 225K. Now, just to give you context as far as how that is calculated, if you were to apply this formula to that 225K, you would have the minus 225K at the top, and at the bottom you would have 1 plus this rate of return of 12%, which is a 0.12, and all of that to the power of 0, and anything to the power of 0 is 1. So there's really no need for you to apply the formula for year 0 because it will be that same amount. Okay, but just to put it in context, I'm showing it here. So that's year 0. Then we have year 1. And again, this is where your calculator will come in handy. You absolutely need a calculator to be able to pull this off sensibly. But let's go ahead and take a shortcut. In the interest of time, I would suggest that you use your calculator to follow through. Year 1 will be 95,000 divided by 1 plus 0.12 to the power of 1. And when you do the math, that will give you 95,000 divided by 1.12, because anything raised to the power of 1 is that thing. And when you do the math, you're going to get 84,821.43. In the same token, you'll do this for year 2, and the investment, the cash flow rather, is going to be 80K divided by 1.12 to the power of 2. And when you do the math, you're going to get 63,777.53. You do the same for year 3, and you're going to have 60K divided by 1.12 to the power of 3, and that will give you 42,710.10. And finally, we do the same for year 4. And the amount flowing in to year 4 is 55,000. We divide that by 1.12 to the power of 4, and we get 34,947.17. What you should do at the end of the exercise to bring everything together is to add up the 225, this amount. Remember, it's all dollars. Don't forget your dollar signs. These are all dollars. You add all of these up meticulously, and when you add all of those up, your 225,000 investment will very quickly be cancelled, obviously, but you end up having an NPV equals 226,256.23 minus the 225,000. And what you're going to end up getting is 1256.23. So what we can see from this is we are not going to lose money. Instead, we're going to gain 1,256,000. Now, if you were to use the actual computation, you get something around 1257, perhaps, something like that. So since this is a positive number, What can you deduce from this? Because it's positive, you're going to gain. You're not going to lose. Now, this is a more extreme problem, which I sincerely hope no one gets on the test. As opposed to it being so laborious, having 4 years listed out, what you typically would have is just 1 year flow. And when you have 1 year flow, it becomes easier for you to deal with. Now, bear in mind, this right here, you could look at this as future money coming in, future value, right? So if you were going to rewrite this formula in the context of future value, just in case you ever get something like that, you could say net present value is equal to the future value, which really refers to those cash flows, divided by 1 plus the discount rate to the power of t, where t is time, or to the power of n, where n is a number of years, right? And that's how to work it. If you have multiple years, you need to apply the formula to each year and then add them up. But I don't think you would get anything so extreme on the test. But hey, you just never know. So you might want to circle back and review this a few times. Now, let's talk about the overarching implication of net present value. Because net present value could be summed up like this. If NPV is positive, good. If it's greater than 0, that's good. If it's less than 0, then that's bad. And if it's equal to 0, then you're neither losing or gaining. So let's summarize that final conclusion. Okay, so the summary is this. NPV greater than 0, accept. NPV is less than 0, don't do it. Reject the project. And last but not least, if NPV is equal to 0, it depends on strategic factors. Because you're neither losing or gaining, so your decision to work the project is dependent on other things. So this used to be a regular on the PMP exam. Should you accept the project? Should you reject the project? And so on. There are a number of other metrics that come into this discussion. There's IRR, there's BCR, and there's payback period, and of course NPV that we just talked about. So if you get a question that gives you various internal rates of return, you always choose the highest IRR, right? If you get a question that presents many benefit cost ratios, always choose, again, the highest benefit cost ratio, because it's the ratio of benefits or revenue to cost. So think about it. You're getting revenues of 30K and then the cost is 5K. You're getting the 6 times, right, the cost. So the higher it is, the better. The higher the BCR, the better it is. Payback period, you want the lowest payback period. Would you choose a project where you can get your money in 5 years, or one you can get your money in 1 year? Of course, the 1 year, right? So always choose the lowest payback period. And for net present value, always choose the highest net present value. So if you have 5 projects and they all have different MPVs, you want the highest MPV. Again, going back to my summary here, if it's less than 0, reject it. If it's greater than 0, that's good, but you can have many that are greater than 0 and you want to select the best one. All right, so again, this topic, I just realized on social media, people talking about this topic again. I wasn't expecting to see it ever again, but it seems to be coming up on the test. So you might want to like make sure you at least have this in your back pocket just in case. All right, I hope this helps. All the very best on your PMP exam. Bye for now.